law school is three years of how to think like a lawyer, how to analyze. I never wanted to be a lawyer. I was plenty happy being an engineer, going all over the world building plants.
It made you be a lawyer, right?
They actually asked me, basically what happened was the laws that were written were so crazy that the company goes, "You're the youngest one here. You're going to law school." What? Thank you.
And they paid for you?
Well, regular 8 to 10 hour day as an engineer. Go to school at night. All year round for 4 years.
Yeah.
And, but they paid for it.
That's good.
So I'm passing something around. I want you to take a look at it and then try to figure out what it is. Okay? So before I start talking about trash, I'm going to ask you. Remember we talked about the banana peel, the glass bottle, right? Cigarette butt, plastic bag. Okay, that's just litter. So if I put it in a landfill, I'm just going to give you a city, San Diego. I just stick the trash from your home, stick it in the ground, cover it with about 2 feet of soil. There's no plastic liners or anything like the modern landfills. It's a very old landfill, and it rains and stuff. How long do you think that trash will take to decompose? Just household trash, how long does it take to decompose? If I stick it in a landfill with food waste and yard waste and all this other stuff, all mixed together, covered with 2 feet of soil,
50 years.
50 years, decompose.
Yeah. Like all of it completely decomposed.
Yeah. When things decompose, it turns into like humus material. So how long do you think trash takes to decompose in a landfill?
Depends on the right?
Well, just household trash.
100 years.
100 years.
30.
You have to say something. 1 year? 4 years. Okay, so now we're going to start looking at some trash. So here's the rule. Before you eat anything anymore, you wash your hands. Okay? Because I'm going to pass this around. This is what happens when you're in your trash business. They dig up a landfill and they drop it off at your front door. So I want you to take a look at this trash. This came out of a landfill in San Diego, buried 2 feet under 2 feet of soil. And the date on the newspaper says 1956. Okay? There was a hot dog in here, but my wife made me throw it away because it was pretty damn disgusting. It looked actually edible. Okay? Here's the bottom.
That's a bottle right there.
Still there. There's pieces of wood. You take a look at this. I want you to, you can touch this, it's okay. But wash hands before you eat. Okay? Pass this around. This is the problem with trash. An example that I gave in the beginning, the banana peel or the chicken outside the cage, trash decomposed. But when we started burying it, when we started becoming urban societies, we created landfills. This stuff does not go away. Okay? So this is trash. From 1956. Yes?
Isn't it also hard for it to compose because of the sunlight and oxygen and all the moisture is not able to like, get on the material? Is that what?
Because the way we build landfills in California is like a tomb. It's a dry tomb.
Yeah.
So in California?
Well, we're kind of a desert here, right? Yeah. In other parts of the country, they actually inject water to make it decompose. So there's many different theories. But our laws in California say keep it dry because we don't want water going through it and then going into groundwater. Okay? So like we said, the trash that they take away from your homes, it goes to the landfill, it never goes away. In other countries, they don't let you put this in the landfill. Because what happens in a landfill, even though it's dry, it still decomposes very slowly. It gives off explosive gases, gives off methane, gives off CO2. That's what the cause of climate change. So other countries basically ban landfills for the very specific purpose of reducing the carbon footprint, trying to reduce the climate change impact. And they look at our trash and say, boy, you're kind of behind. And in reality, I will show you later, we're about 25, 30 years behind other countries, some of the more advanced countries in this field. Okay? That's a piece of wood, you can tell, it's not
Yeah.
going anywhere, right? Okay. So where's that little plastic bag with this? Okay. Did you guys figure out what that is?
Banana.
What?
It's a banana peel.
Nice try.
Plastic foam.
Cigarette butt.
No. Okay.
Something with styrofoam.
No.
Styrofoam cup?
No.
A shoe.
The white thing is a honeydew rind. The brown thing is a cantaloupe. This is what's left after one day sitting on a pile of worms. So the worms eat it. So there's actually a waste diversion practice, a recycling practice called vermiculture. People have worm farms. They actually feed food waste and they eat it. So 1 pound of worms will produce a half a pound of worm crap. We'll call it castings, we don't call it worm crap. Yes, and they actually sell that. It's very, very valuable. It's one of the best fertilizers available. So it's, like I said, there's many different ways to recycle waste. But that's what it is. Okay? Okay. Now we're going to get into the nitty-gritty. So, this sheet. This is the official, this is actually in the regulations. We'll probably do something a little bit different, so we'll start. And then I kind of gave you the definitions of each of the materials. And they're not going to be consistent. But I want you to look at this sheet. You know? Huh? I want you to look at this sheet. So let's learn the official language of this industry. So you see at the very top left, it says section, category, type, and subtype. You see that? On top left here. Okay? So if you look down here, this is actually in our regulations. You see that number, 18721.1? That's actually, we call that the section of our code, state code. We don't care, but officially it's called the section of our regulations, okay? So you see the word paper, glass, metal, see those big, broad categories? See that?
Mm-hmm.
We call that, if you look at the top left, that's, when we say that classification, that's a category. So newspaper is part of the paper category. You understand that?
Mm-hmm.
Okay, the next level down is material type. So we have material category and material type. So is office paper, is that a category or a type? Type, okay? So under office paper, we have colored ledger. So is that category, type, or subtype?
Subtype.
Okay, you got it. So if we wanted a very detailed sort, we can say, I want white paper, color ledger, computer paper, and office paper, right? But if the people buying the paper doesn't care, if you just take it all the office paper, we can just put it all together. So we call that roll-up data. So you can put white paper, color ledger, computer paper, and other office paper. If you wanted a simpler sort, instead of 4 separate bins, you just have one bin that says office paper. You see that? So here's the rule for characterization. You always try to get as much detailed data as possible, because you can always aggregate it or add it together. But if you only do it at the higher level, you can't disaggregate it. So allowing for resources, we always try to do the most detailed possible. So that's kind of the fundamental design of how we put together a race characterization study. Understand that? You can always add the data up, but you cannot separate it if you only do it at the higher level. Okay? So why would it be important to separate computer paper from other office paper? Can you think of a reason?
Other office paper could mean it's colored, and that means colored fibers.
Well, we have a classification that says colored ledger.
Probably different materials and different
Different
papers.
fibers in the papers.
Well, it all comes from a tree. Yes, it's actually all of your answers are correct. Okay, a lot of it deals with the color, how the paper is made. There's many different types of computer paper, but generally,
Wax coated.
yes, but generally computer paper, the old type, where they run it through the machine when it's all connected. When it's all connected and it's high speed, think about it, that paper's got to be pretty strong. So the fibers are very long. So what makes paper valuable is the length of the fibers in the paper. Understand? So remember what I said, we're not just going to learn about how to sort this, but you have to understand why we're sorting. So if the office paper, you may get $50 a ton, $60 a ton. Computer paper, $200 a ton. So it makes a little bit of difference. So how recyclers make money is you give them all your paper, they go, oh, it's all mixed, I pay you $50 a ton. He separates out the $200 a ton, and he sells that 200, he sells the other stuff at 50. When you mix it, the value is lower. Got that? That's called high grade. That's how they make money. They collect everything, they put the extra effort to separate the more valuable stuff out and sell it at a higher price. So here's something for you. You know that you see those people driving around picking up cardboard, picking up metal, right?
Yeah.
Pick up trucks.
Mm-hmm.
You know, you saw a lot of people call them scavengers. You know, they're really recycling, but it's not an official city program. On average, do you know how much they make a day? And this is tax-free. No.
Like 300?
It's
200 to 300?
80 to 150.
It's about $150 to $200 a day.
That's,
If you're smart about it, and when the market's good.
yeah, I spoke to a couple of them and they told me that's what they get.
Yeah, it's pretty good.
And they go to LA to go,
Mhm.
like all their,
Okay. This is why other countries think we're crazy for throwing all this stuff away in the landfill. Okay, so now let's start on paper. Okay. We're gonna learn about the material type. We also have to learn about why they're classified this way. Remember what I said about this scheme, this protocol characterization. It is for the purposes of identifying what is recyclable. Okay, do you hear what I said? What is recyclable? You have to understand why the materials are grouped the way it is, because this will help you understand how to sort. So if you look under the material type, uncoated corrugated cardboard and paper bags. Why are they together? Why are they in the same material type? So I am going to find a brown paper bag. So this is a brown paper bag, right? So, and this is cardboard. How can we put this together in the material type?
Fiber color?
We can separate it for more detail. Why would we be able to aggregate? Why would the recycler buy it like this?
isn't it because some of them are coated and some of them are not?
No,
Why would they buy it like that?
Yes.
Like mixed?
like this. Why would they buy this mix?
Because of the high grading process, maybe?
That's kind of right, but not the answer I'm looking for. So remember what I said. I want you to think about the reason. That's more important that you understand. Hmm? What did you say?
Fiber color?
Fiber
Color?
color? No.
Fiber type?
Material? Well, it's semi-material.
Hazardous, maybe to the flatland?
The same type of fiber.
Same type of fiber is the right answer. So pretty close. So here it is. This is a grocery bag. So you put a lot of groceries in it. What's the function of this bag?
Packaging.
Hold the material.
Yeah, this is actually a non-durable good. This is packaging, okay, cardboard box. So it holds things. Cardboard box, what's the purpose? Holding things, right? Do you know that cardboard is actually rated? There's a what we call a strength rating. So if I'm going to pass this cardboard around, so you can see that this is a multiple layer piece of cardboard. It's rated for 900 pounds. This isn't. This is because this is multiple layer. What makes cardboard strong? It's not. See, you see the cardboard here? You have a layer of paper, and you see this like this, right? And you see another layer. You see this layer? This is called craft paper. It's the same as this. This is very long fibers, so it gives you very good strength. Remember why is paper valuable for recycling? So it's the longer the fiber, the more valuable it is. The stuff in the center is just to keep it apart. It doesn't have very much strength. It's not very long fiber material, so it's a different type of material. Okay? You can feel the difference. So I'm going to pass this around. But this material in the bag is exactly the same as the outside of this. That's why you can put it together. So now do you understand why the scheme is written that way? These are both recyclable. But what's really valuable in this is really this. So what can give you more money? A ton of this or a ton of this?
A ton of the bag.
Yes, because you don't have the weight of all this stuff inside, right? Which is called groundwood pulp. Groundwood pulp means that they use a mechanical process to grind the paper fibers, so it's much shorter, it doesn't have the strength. That's not the purpose of that, that's for cushioning purposes. So when you look at materials, try to figure out why is that material there, what is the function? You'll really appreciate what you're doing much better. So I'm going to pass this around. So now you learned why things are grouped together the way they are. So now we learned cardboard. We're learning about cardboard.
About how long does the long fiber last? How many times can it be reprocessed and used before it becomes short fiber?
About 7 times. 6 to 7 times is the practical life of something being recycled.
Could be reused 6 or 7 times?
No, it can be reground. So every time you send it back, they grind it, they pulp it again,
Yeah.
and they make another cardboard, they make another piece of craft paper.
Do that about 6, 7 times?
Yes. So how many of you have actually been to a paper plant?
Isn't there one right here by Burke?
Yes. Okay.
Is it?
Do you know the chemist that invented that pulping the cardboard thing, the material?
Wait, say that again?
The one that invented it, the chemist, do you know his name? Was it Carl something?
Wait.
The one that invented like pulping, like spice material to make cardboard.
I don't know. No. Okay. So I'm gonna. Okay, so what is all this material here? So you have to say something. Huh? No, that's a good answer, but if we had to use the classification on this sheet of paper, what is this?
Coated, coated, corrugated, cardboard.
Okay, I'm gonna say, anytime I hold up a bunch of stuff, don't ever give me an answer. Because this all looks like cardboard, it's not. And this is how detailed we have to be in a characterization statement. And it matters for how valuable the stuff is in the waste stream and for equipment manufacturers.
This is not cardboard. This is not cardboard.
Okay, why is this not cardboard? It has,
Has a wax coating?
yes. It has a wax coating, so why does that make it? Why can't you put it in an uncoated? Well, because it's coated, that's one answer. But why is this not traditionally recyclable?
Because of the wax?
Remember, these definitions were actually written in 1989, 1990. So at that time, it was what was termed traditionally recyclable. In 1989, this was not traditionally recyclable because this wax, can you see, you can run your finger, is that wax coming out? See that? So you can do it, go like that. What's the purpose of this? Keep your oranges fresh, keep your fruits fresh, right? So when you pulp the paper, this wax gummed up the works. So it's basically considered a contaminant. So if you had a certain amount of this coated material, this material with the uncoated stuff, they would reject the whole bale. Okay, so we have a category for this. Even though it's cardboard, we can't put it in the uncoated. Okay, so where would it go?
Paper bag.
No, is this a paper bag? Okay, see how, this is why learning to think is more important.
Remainder composite
Yes,
paper?
remainder composite is the catch-all for the stuff that is not traditionally recyclable. So if you have doubt, of course you can ask Scotty and Carl and Joyce, you put it in remainder composite. Do you understand?
Yes, sir.
Okay, so I want you to go like this and take a look. Okay. This is the back, see, these are exam questions. So I have a bet usually with my engineering class that I'm gonna give you 100 of these. If you can get 90 of them right, I will take you to dinner. It has never been collected on in 30 years. Okay? And when we get through today, you'll understand why. So this is the back of your writing tablet. This is like your cereal box. What is this? Is this on this list? So where does this go? I want you to think. I'm not going to tell you. I want you to think about this. Where does it go? I'm going to pick on Terry here. It's okay to screw up.
Is it?
Is this cardboard? We call it cardboard.
Yeah, we sure do.
Right? Remember, I'm messing with your mind.
Other miscellaneous paper.
Other miscellaneous paper.
Yes.
Let me see where.
Right there. Miscellaneous paper and then other miscellaneous paper.
That's not paper bags, I think it's that's.
Okay, Terry. We have answers from the crowd. So you guys, what do you guys say?
Other miscellaneous paper.
Don't listen to them.
Remainder.
Subway dinner.
I am going to be making my hand very bad today.
Okay. Uncorrugated cardboard. I'll just guess.
No, they are right.
What, I didn't hear what they said.
Good. This is chipboard. We call it cardboard. This is like the inside of your paper towel rolls, the rolls inside your toilet paper. This is chipboard.
That was a trick question. I don't have chippies.
That's all I'm going to give you is trick questions. That's the only way I can make you think.
Yeah, it ripped off.
It's going to get worse.
Can you feel the difference?
Absolutely. Because you can tear this, you can actually see the length of the fiber compared to the craft bag. So that's what I want you to do. Okay? Okay. Is this cardboard? It's not wax coated. Is this cardboard?
Corrugated.
It's corrugated. Is this cardboard? Where does this go? If you tell me this is not cardboard, you better tell me where it goes. It's got to go somewhere. It's got to go in one of those bins.
Cardboard?
Look at me. Don't look at the thing. Look at this thing.
I'm looking at both.
Touch it, smell it, don't lick it.
Looks like it's got waste, so I put it in the unclassified. Looks like it's got waste.
There is nothing called unclassified. It is not wax.
It looks like wax, but it's not wax.
It's not wax.
Some covering on it.
Where does it go? You have to say something. You can pass it around.
Remainder?
You're saying remainder. I'm going to come to you last, Terry,
Okay.
because you're always going to get it wrong.
Phone books and directives?
Uncoated.
Is this a phone book?
No, but I'm thinking it's the same type of.
Well, if it's not a phone book, it's not a phone book, right?
Maybe
That's
the
okay.
same type of material.
Good mistake. You won't make it again, right? Okay.
No, it's not that. It has to be.
This is not wax coated. It is a computer box, part of a computer box.
The office paper.
Terry?
That's what I was thinking.
Huh? Composite? Yes, remainder composite. Why? This is plastic coated. Why is there plastic coating on a computer box?
Protected?
Hmm?
Protected or?
What do you mean to protect it? Protect it from what? Dropping? No. Think of why it's there.
Make it sturdy.
No. Somebody had the right answer. Moisture. Keep it dry. Okay, I'm gonna let him answer first.
There you go.
Is this cardboard? And I'm not gonna, don't say anything, because I don't want you to give him any clues, because we're picking on him.
It doesn't look like cardboard. It's got the same pattern as cardboard, but it doesn't really look like cardboard.
Okay, so I'm gonna pass this around, and you tell me if that's cardboard. Okay, I got another piece that's similar. Um, Okay, so as you can tell, I collect trash from all over the world. And I cannot tell you how anxious my wife is to have me retire so she can burn the damn garage. Same thing.
Because it's not colored.
Same thing, yeah.
It's not colored, it's still colored.
Is this cardboard? It's corrugated, it is uncoated. It is actually called cardboard. Okay? I'm telling you, this is actually called cardboard.
That's not how we sort it.
How do you sort this?
Other office paper.
Other miscellaneous paper.
Uncoated corrugated cardboard?
That is the way that people call this, they call this uncoated corrugated cardboard. Okay? So where do you put this when you sort it? You have to learn how to recognize the differences.
I don't think that goes into uncoated corrugated cardboard section.
Well, if you didn't know any better, if you never saw this, where would you put it?
Uncoated corrugated cardboard.
Okay?
On paper bag.
Remainder composite.
And actually, it would actually be acceptable in uncoated corrugated cardboard. Okay? Where would you put it? I only was waiting for you to say that to tell you you are wrong. I am picking on him. Why? You look at this and tell me why this would not be uncoated corrugated cardboard. It is called uncoated corrugated cardboard, but we do not put it there. Why?
The outside's not the same fibers as the cardboard.
You put it in
Wait a second, wait a second. I'm gonna pick on the back row because they sat in the back to hide from the front. So, let's hear from the back first. Why, even though this is called uncoated corrugated cardboard, why would we not put it there? And where would we put it? You have to say something.
Back row?
It all looks the same to you, right?
It's the same.
A little bit different. You guys have to keep an eye on this guy.
Fired.
Yeah, I think on everybody, you all get equal treatment. You get to come in later. Okay, so I'm gonna pass this around again. What makes cardboard valuable? Fiber,
The length of the fiber.
strength of the craft. Does this have craft?
Yes.
No,
Yeah.
What was the craft again?
there is no craft. I wanted you to see the color. I wanted you to feel it. So here's the thing, it's gonna go around again. I want you to take this piece of cardboard. I want you to try for you to take your fingernail. Give nice fingernails.
So this is corrugated cardboard, short fibers, so it's not as strong.
Yes, this is actually, there's no value to this. This is very little. This is probably worth about 20 bucks a ton, 200. So, wait, I'm gonna send this around. I want you to take your fingernail and go like this. You try to do that to this. Don't break your fingernail. We need good fingers for sorting today. So, okay, you first. Take your fingernail and go like that.
So what's the difference then?
Yeah, the different fibers, so that one has a shorter.
Okay, try that.
So
Yeah,
it's
'cause
less
it's
sturdy,
easier.
and the cardboard has longer
Got it?
fibers.
So that's the
longer
string.
fibers, the more
Stronger.
valuable.
See how fast this is?
What about the weight?
Break your fingers. What? Well, what about the sizes? Can't tell you. You have to be able to recognize this. You have to be able to recognize it. Okay, you getting some idea of the complexity? Okay, most sorts are not done to this level. This is what we have to do. Okay? Pizza box. Where does this go? Depends on how dirty, so this is pretty clean. So where does this go?
It's got long fibers. Other than that,
Yeah, good thinking process.
so I would.
You can laugh at the front row, but I'm picking on you guys. So where does this go? Okay, you have about 1 second per item to make the decision. We're gonna do one sort today. An experienced crew can do 10 to 20 samples a day. Okay? So you have to learn to fly very fast. So where? No, this is cardboard. This is uncoated corrugated cardboard. Unless there's a giant pizza stuck. Okay? Okay,
Quick question.
yes.
So now, let's say that the uncoated corrugated cardboard for the pizza box was soiled with food. How would we handle that? Would that be remainder composite paper? Or would we?
For our purposes, we put it in the cardboard.
Okay.
Okay, here's the note, kind of in between. So where would you put it? This is not quite that, but it's not quite cardboard, so where do you put this? I'm taking on you first.
Okay. It's got long fibers.
Here, it's strong and it's long fibers. So, did you answer my question?
No, I was dodging.
Well, I was talking back to you. Uncoated, he says uncoated, so what do you say? This is somewhere in between. What would be a good test for you guys? If you were buying and selling this and making money, how about just going like this? Yes. Okay. Miscellaneous paper. Got it? Okay. If you're gonna err, you should be conservative about how you characterize. It's probably much better to put this in the miscellaneous paper than the cardboard. So part of the philosophy that we use is, try to be conservative in how we characterize. Okay? It's better to underestimate the amount of revenue you get than overestimate. Starting to learn some of the principles. The problem is, for these composition studies, none of this stuff is written down anywhere. So I know we have to try to write all this stuff down, but I'm trying to give it to you verbally. We'll try to get it all written down. So let's pass that around. Okay. You guys recognize what this stuff is? You guys know what kind of paper this is?
Drafting paper?
Can I touch it?
Is this computer clock?
Yeah.
Do you know what this is? What do we call this thing?
Something colored, what is it?
What do we call this? Blueprint. Right? You're dating yourself. You don't see too much of this stuff around anymore. You said magazine, right?
It's not magazine paper. I don't know.
remainder composite paper?
What are these?
Magazines.
Coated.
What are these? These are magazines. So where does this stuff go? Where does this go? Do we call these magazines?
No. Oh, yeah.
Do we call this magazines?
Miscellaneous paper.
Do we call these magazines?
I do.
You do?
I'm wrong.
Of course you're wrong. What was my rule? I said I was gonna do, I was gonna mess with your minds. Whenever I hold more than one thing up, don't let me do that to you.
Oh, yeah.
Is this a magazine?
Yes. Yes.
Yes. So where does this go?
Magazines and catalog
Magazine.
section.
Is this a magazine?
No.
No.
Actually, it is, but can you put it in the magazine?
No. No.
No, you could, but it's not right. Why?
It's not a magazine.
It's the kind of paper it is,
Different
okay?
fibers.
It is completely different than this. This is actually, it's a little old, but this is actually white ledger. This is actually office paper. So this is worth $25 a ton. This may be $100 to $150 a ton. You mix this together, you get $20, $25 a ton. They go like this, they make a lot of money and still make money. Got it?
You don't want to contaminate valuable material.
You don't want to put both of these in white paper. It's okay to do this in magazines, but the accurate, what I want you to do is white ledger and magazine. You understand? This is important because it's going to get more complicated. And we're just doing the simple stuff, paper. Okay? Was this what you thought this was going to be like? No. If you thought it was going to be like this, it's going to get a lot worse. Okay?
What about the inside of the magazine? Is this shiny too?
Well, that's just the coating.
Oh, okay.
So let me.
Magazine shiny.
So I'm gonna assume everybody's seen a Playboy magazine, right?
Edit that out.
Don't want my wife
Different
to-
kind of
she don't
magazine.
mind. Okay. You ever noticed how heavy the magazine is? Remember that? What does, or how about for how about Architecture Digest?
Oh, there you go.
Okay, his kind of magazine, right? Okay, Playboy for us. Okay, you ever notice how heavy Playboy magazine or Architecture Digest is? You understand why it's heavy?
Low on the paper.
Do you know what's in that paper?
Extra plastics.
No.
Non-fibers.
No. No.
Wax.
Why do you think they could charge you more for those magazines?
Because of the ink.
Because of the pictures? No. Think paper, not pictures.
Because of the demand. The white ledger.
The weight of the paper makes you think it's a higher value product. Do you understand? It weighs more. Oh, it's more costly. The reason it weighs more and it's shiny, you get good color, it's coated, is because the paper, there's paper fibers in there, but there's clay. You know what clay is? It's just dirt. There's clay in that paper. That's what adds to that weight. So for like those magazines, we don't put with this. You understand? It's still a magazine, but it's not as good as this, which is all the weight of this. A ton of this is worth way more than a ton of Architecture Digest, and because of the amount of paper, this is much more paper fiber than, because the weight, most of that weight in Playboy magazines is going to be clay. It's dirt. Gives you the weight. So how many of you actually felt a lead crystal? It's heavier than regular glass, right? So it's, okay, you have no idea. You have the perception that it's worth more, it's shinier with all the chemical makeup. We'll get to that. So, okay. So this is blueprint. Okay, so I got sidetracked by magazines. So blueprint, where does this go?
White ledger.
Is this a directory?
No.
This is a directory.
Colored ledger.
But it's more properly in white ledger. It's more doing by material type that you can sell for recycling.
White ledger?
Color.
No, this is blueprint paper. I'm telling you what it is.
Other office paper?
To be good in the trash business, you cannot just be good in one thing. You have to know a lot about everything. Okay? You'd be surprised the knowledge breadth you have to have.
Other office paper?
Is this other, I will tell you, well, I'm gonna, of course, I'm gonna leave you alone today, for now.
This should be, I think, office paper.
Because it comes from an office.
No, I think it should have long fiber.
Guess what? It has long fiber. It is not white ledger. It is not miscellaneous paper. Why? I said this is blueprint paper. And maybe it's not a fair question to you because you guys are all so young. So I'm back to picking on Terry. So why is it not office paper?
Is it the size?
No.
Because it's can't be treated.
The fibers?
Yes. Like photographic papers, this has chemicals in it. And paper recyclers don't want this. Yes, I know. So, if a lot of this, in the older days, we actually put this with remainder composite because it had chemicals. Although if you have a lot of it, people will recycle it. Okay? So understand that's actually where it traditionally went. But over time, okay, same type of drawings. We don't use blueprint paper anymore. It all comes like this, so where does this go? And if you see blueprint, remainder composite for us. We're gonna, at least for the purposes of this exercise, remainder composite. When we have to decide when we actually do the study, whether it goes remainder composite or actually other miscellaneous paper. And I am actually for other miscellaneous paper now. Because we will change the definitions. But this is why things change over time. We look at marketability as the determinant. So where does this, this looks like a blueprint. Where does this go now?
I see either white ledger or other office paper.
I say white paper.
White ledger? They're saying this is the highest grade paper. What do you guys say? Oh, actually, that's the second highest grade. Computer paper is first. Okay.
Other office?
Well, with computer paper and cardboard. So where does this go, guys?
Other office paper?
Other office paper? So I'm interested in your thinking process because you have to go through this thinking process like that when you're sorting. So why did you say other office paper? So let me hear your thinking.
The way it looked.
Because the way it looks?
It looked thinner than I thought it was.
No. I know it's two sheets, but these are exactly the same thing. Okay, so the way it looks,
Computer
it is the way it looks. It is not computer paper. White ledger? You guys are quiet in the back. Come on. Huh?
Other office paper?
This is white ledger. Okay? So you have to kind of understand large plotters and stuff. It just uses white paper. Okay? So this is the same thing as this piece of paper. Understand? So this is very valuable. So this is white
So
paper.
the ink does not consider it contaminated?
No, it's not. But it's very different than blueprint. You've got to be able to recognize the difference.
Well, the blueprint was made.
You won't see too many blueprints. This is just like office papers. It's like this. I mean, this white office paper.
Well, the blueprint was just made to produce like a translucent document, wasn't it? Is that what added the chemical coating to it?
No, this actually goes through a blueprint machine to have it uses got traces of chemicals on it. Okay, and it's a very specific paper with chemicals in it too. Okay, so a couple more. Okay, this is an easy one. Terry. Come on, guys.
Yeah, so that,
We don't use full trash.
Remember my rules.
Office people.
What was my number one rule?
Don't mix.
If I hold up a bunch of things,
Don't
give me an answer. He is not paying attention. Okay. I'm only holding one thing now. You sure? Good, I've got him going.
Colored ledger. Colored ledger.
Good answer.
Other office paper.
I want the most detailed. What is it? Look under paper, where should this go?
Computer paper.
You gotta know how to look for.
Phone books and directories.
Is this a phone book or a directory?
No.
Okay, I really confused you. So, yes, I do know you're confused, and you're gonna get more confused, but hopefully in the last hour, and after that, it's clear.
Computer paper.
That's okay. Okay, some things are very obvious. This is computer paper. This is, what's the giveaway? It's actually connected. So it's got to be high speed, high strength, right? So computer paper, very valuable. It's got a little green bar. We call this green bar computer paper, but this is still computer paper. We'll get into color paper later.
What are the green bars?
But this is just for easy reading for the numbers. No, it's smaller. Come on. We're going to be here for 3 days. No, I want a finer classification than office paper. You're taking the easy way out. Color ledger.
I say it's a color ledger. 'Cause it's not connected. It doesn't have high-speed fiber. Color ledger, I guess.
Okay, I'm going to keep messing with your mind. What did I say about holding two things up?
Not so answer. They're not the same.
Okay, how many times am I going to do this to you? Okay, I want to start putting money out. Computer paper. This is not computer paper. But if you put this computer paper with white ledger, is this okay? Yes. You can, but this is computer paper. It's got just the little rough edges that's actually torn off.
What makes it okay to be?
Because computer paper is worth more than white ledger. So if you downgraded it, it's probably okay. But more properly accurate, it's computer paper. And the way it's given away is green bar. Okay? Why is this not computer paper?
Other office paper?
No, you have to give me a better class. I mean, that's an okay classification, and that's actually correct. Why is this other office paper and not computer paper? Yes?
It's not as durable and strong like you said. It needs for that fast action.
It still does that, but you're right about the not as strong. Can you tell by the color? Okay. $150, $200 a ton, 25. What is the difference? I can smell it and tell the difference. I don't expect that of you.
Like bundle paper.
Yes,
long and short.
correct. Long fiber, short fiber. This is, you can take it, please don't tear it in half, but this is very short. This is the same as newspaper, which is the very, very short fibers, mechanically ground. So this is worth very little. This is worth a lot. And the only way you can tell is you can actually look at the paper. This is actually aged. That's a couple of years old, so it browns. So you notice if you put a newspaper out in the sun, it gets brown after a while, right? That's because it's just not very long fibers, and it's not chemically processed. It's just ground, mechanically ground. So this is actually long fibers, chemically treated. This is mechanical, short fibers.
We should go through the process first before we start.
Okay, I'm waiting.
Yeah.
So what we're trying to do is to look at the different sizes of a specific type of material. What's really important about this is that in order to get away from hand sorting, we'll be using machines. And one of the primary machines that automated MRFs use is a screen. Not so much a screen that looks like this, but they're what we call them trommels. They're like rotary screens. There's a giant steel tube with holes in it of different sizes. So if we know the trash has a whole bunch of different sizes. So if you kind of walked around, you notice the cardboard is pretty big. So if you put it on here, the cardboard's going to stay on top. Whereas if you look at the food waste, it's all very small. So if you put food waste on here, it all drops through. So we call that a unit process. So a screen of one size is a unit process. So if you only had food and cardboard, and you had to do one thing to separate it, you can pick a screen that keeps the cardboard on top and the food falls through. It would be a lot smaller than, it wouldn't be this size, it would be a little smaller. You could do something even like 6 inches and most of the food would fall through. So we call that a unit process because it actually concentrates all the food waste at the bottom and it keeps the larger stuff, drier stuff, the cardboard on top. And so a lot of the automated facilities use a whole bunch of different unit processes, different screens. It doesn't have to be the rotary screens. There are the finger screens. There are all kinds of different types of screens. But basically, it works on the principle of size. So what we're doing is we're going to look at the size of the trash in Oxnard by material type, and we give this information to the people who's going to be providing equipment or bidding on equipment to upgrade the facility, so that this doesn't have to be done by hand. So the concentration of the food waste can be done by machines. So what we're going to do now is go through a series of screens for each different type of material that we collected. This is not going to be the most efficient way, but it is the most efficient way for you to learn. Because what we're going to do is we're going to take that one container, we're going to put it on here, we're going to shake it. It's a combination of this and a little bit of this until it has the separation. Okay? We're going to take what's on top, we're going to weigh it. And then whatever we weigh, after we weigh it, we're going to throw it in that big box over there so we can measure the density later. The stuff that falls through,
That circle, the cube box over there.
yes. So the stuff that falls through, I want you to take a look at it to see how different it is from the stuff on top. But every time we have a screen, look to see what remains, look to see what goes through. And that's how you learn to get a feel for what the size differentiation is in the trash. Okay? So once the stuff falls through, we have to kind of sweep it all to one side and collect it again and put it on the next size screen. We repeat that process. We weigh the amount that's retained on top of the screen for each screen, except for the very last one. We weigh what's on top and we weigh what falls through. And then we put it in the big 1 cubic yard box. Got it? Okay? Is that pretty simple? Yeah. We don't have to work fast. We've got a lot of things we have to do. And the materials that there's the most of in the trash, we'll have to do this several times over the period of this week and next week. The things that we don't have much of, we have to collect until we have a good amount that we can actually do this. So we're not going to be doing everything in one day.
So we're
Got it?
doing the whole bin?
Yeah, we're going to do the ones with the overflow bins first.
Like the ones that are using more than one bin?
Yes.
Yeah. All right.
Yes. And of course, there's more of that stuff in the trash, so, and it's more important to get good data on that. So we're gonna do that, then we're gonna do it more than one time. All right?
So the material on top, we're gonna call that over. The material that's on the bottom, that's on the table, we're calling that under. So later on when we do this material, right, when I say over, that's stuff that's still on top.
So the stuff on top is gonna go in there?
It's gonna be thrown into a bin and then we're gonna weigh it.
We're first going to weigh it each time in a basket or whatever, so we know how much stayed in the top, right? The over, right?
Yes.
And then until we finished everything, and then it's all going to go into that density box over there, and then, you know, the wood boxes with the handles over there, and then we're going to put a ruler in there, figure out how much of a cubic yard it is, and then we'll do the calculations later, and then we'll know exactly how much 1 cubic yard of that kind of material weighs.
So whatever
it's
falls,
two different studies.
So whatever falls through is gonna be under. We're gonna push it over, lift it, and the under will become back on top, and we're gonna sift it again. It's like mining for gold. We're gonna keep on doing it until we get down to like nothing.
Okay.
Okay?
Do you have a ruler?
So we're gonna do that.
It should be 20 inches. We should just write 20 inch on the side so you guys know.
Okay, so we're gonna have 2 guys shake, 2 guys pour.
Okay.
Right, and then we'll rotate.
Okay. Don't pour it all at one time. Just do it so it's manageable. Okay. Remember that safety is the most important thing.
It's just like when you guys were sorting when it was really high, it sucks, right? When it was better, when it was thinner, it was easier. That's what we want to create. The same kind of feeling.
Okay. No. The size of the mold.
Oh.
20?
20 inch mold.
Yeah.
20 inch. So
Okay.
Yeah.
20-inch square.
Okay. So the stuff that remains in engineering terms, we say it's the 20-inch overs. So the stuff that goes under is called the 20-inch unders. Pretty easy, right? Okay.
Today is sorting through 82 categories from different kinds of loads. From there's self-haul loads. There's going to be green waste loads this week. There's going to be C&D, which is construction and demolition. There's residential loads, commercial loads, and industrial loads. And out of those loads, we have 82 containers that are been marked, and the guys individually hand sort each one of those materials. And if you look at the list, you could see the list of paper, and you see there's 12 categories of paper alone. This is a very, very detailed waste composition study. Then we go into glass, as you could see. And there's the regular glass bottles, but then there's flat glass, light bulbs and stuff, which is remainder composite glass and so forth and so on. Then we got the different kinds of metals, as you can see, ferrous, non-ferrous, appliances. Then we go on to the next page. We've got different kinds of electronics. And then we go on to different kinds of plastics. And most people know as the number ones, which are like the PET bottles. We get our drink containers, and then HDPE, like a milk container. But then we go into a lot more detail of 3 through 7, miscellaneous. So whether it's CRV or non-CRV. And then it goes to different kinds of plastic, you know, and plastic film. And some people think just a dry cleaner bag and pallet wrap is the same kind of plastic, but it's not. So we've got trash bags, and we have a lot of different of the film plastics. And you can see
they added 30 more categories to the sorting.
It was when we started off for our training, it was 52 categories, and now it's 82 categories. And this is according to protocol from Cal Recycle, which is basically they're pretty much the know-it-all, and they set all the standards for all of California. And before that, we had the CIWMB, which is the California Integrated Waste Management Board. So it is a government entity. And so they've rated all these. So we have to look at each one of these films. As you could see from the other page, we have 5 different kinds of film plastics alone that they have to sort and make sure that they put it in the right container. Because all these plastics, if they're collected at this site, at the transfer station when the automated system, they're going to be made into new things, and it has to be the right kinds of plastic that goes with the right kind of plastic. They have different melting points and so forth. We have durable plastics such as toys and old trash can, remainder composite plastics that are really hard to recycle. Then we go down to all our organics, which is food, leaves, grass, prunings, trimmings, manures, and the manure would not be from animals that eat meat. These would be like horses or cows and chickens and that kind of stuff. Then we got textiles and carpets and remainder composite. Then we go more in the construction kind of stuff, which are called the inerts and other. So concrete and asphalt, different kinds of lumber, gypsum board, which is also drywall, rock soils and fines, which is usually we find that we collect that at the end of the table sort. Then we go down into all of our HHW, which is the household hazardous waste. So we have many categories for that. We want to make sure that it goes to the right place, because you don't want to mix hazardous materials together because you don't know what you're making. We got special waste, which would be anything from treated medical waste, which we hope we never get. As part of our training, if we ever see a red bag, we stop our sort immediately, because that means it's treated medical waste and we cannot sort that. Tires and mixed residue. Mixed residue is basically all the stuff at the end of the sort that we cannot sort anymore because it's too small and it would be really hard to collect. And through the MRF, it'll go through the screening process, and that stuff that's at the very end will probably be used for waste to energy, because it's almost impossible to recycle it or to separate it for recycling. So today the guys are going to be doing many different things. They're going to be doing screening samples, as we got the table over there, and there's different size screen. We have 7 different kinds of screens that are made from wood. Materials are going to go, each different kind of material, say white paper or newspaper or whatever, or metals, are going to go through the different kinds of screens, so we know what kind of things will fall through different size hole patterns. And those screens will be used for the new automated system later inside this transfer station here at Del Norte. And then we're also going to do a density test. So we're going to take each different kind of material, such as these plastics we got over here. These is HTPE, non-CRB, non-California retention value. And we're going to put them through, and we're going to put them inside of these containers over here. And these are density boxes. And those density boxes, we're going to fill up as much as the material that we have for these materials. And as we fill this up, we're going to measure with special rulers how full it is. And then we're going to figure out how much a cubic yard of each different kind of material that we've sorted, of the 82 materials, how much room that it takes for that kind of material per cubic yard, and how much that weighs. So after they fill up these boxes, and we've been collecting stuff that was sorted over the last 2 days, and it'll be part of today. And then after, these will be taken on the scale and weighed. And we have a tare weight that's on the front of this. You see the tare weight? And we'll know exactly how many pounds, would equal
right here
for the 1 cubic yard. There you go. There's your tare weight right there. So this is 107.5. So if we fill it up with white paper and we've got 206.5, then we know that we have, what is that? 90 pounds?
You said 207 pounds.
Yeah, there we go. There we go. So anyway, I'm trying to do this quick here. So anyway, so we're going to have the density, we're going to have the screening, and then later we're going to be collecting materials that are going to be put into a dryer unit so we can see how much liquids are in each different kind of thing. Of course, a lot of things get contaminated when they get mixed, and so trying to get stuff away from wet things as fast as possible, or what they weigh wet versus what they weigh dry, is very important. And let me see if there's anything else I could talk about here. As you can see, there's containers all the way around each table where the guys are sorting. It goes from plastics to metals to glass to different kinds of paper, construction, demolition, special waste, and household hazardous waste. And it goes all the way around the circle. And you can see how fast these guys have gotten. This is be their 3rd day, and they're really picking up speed here. And if they're really good, a 200 or 300 pound sample, they should be able to do it between a half an hour, 45 minutes. We're not at that speed yet, but hopefully we'll get there. And we're hoping in the future, a lot of these guys on this team will be part of the management that will help run this new MRF and transfer station into the automated systems.
That's part of the toilet. Yeah, it could be because it's residential, They may change their own boiler bowl. this is how we got the sample to the sorting table in there. It's actually coming from the truckload, which is going there, and then we're collecting it from the transfer station inside, and then get the cross section of the whole load, and then scoop about 200 pounds plus of this sample of the big load in there, as it the true representation for the whole load. And then get the 200 pounds, put it in here on the floor here as our sample pile, and then so this is probably about 200 to about maybe over 300 pounds in here. So we need to get to up to about 200 actual pounds sample, maybe plus a little bit of this. Now, in order to get the true correct sampling here too, from this small pile here, we need to do, call it as a cross section or cross cut of the pile in here, as in also to represent the true sample from this pile. So what we do is that it's probably taking about 4 to 5 loads to get up to 200 pounds of the sampling. So once we have each of these totes filled up, then we wait over there with the scale until we get up to the 200 pounds. Sharpies. Huh? Sharpies.